This is a video from the Exam 4 review in my Calculus 1 class, and we're going to start with problem number 11. Suppose we have the integral of cosine of natural log of t divided by t dt. And so what I'm going to do is let u equal natural log of t. du is 1 over t dt. And so this can be written as the integral of cosine of u du. But this is sine of u plus c. Remember, u is natural log of t, so I can write this as sine of natural log of t plus c. And that's how you do problem number 11. Let's take a look at problem 12. On problem 12, we have the integral of cotangent x dx. What I like to do is I like to think of this as the integral of cosine x divided by sine x dx. And so from here, we're going to let u equal sine of x. du is cosine x dx. And so this can be written as the integral of 1 over u du, which is natural log of the absolute value of u plus c. But remember, u is equal to sine of x. And so this is natural log of the absolute value of sine x plus c. That's how we do number 12. Let's take a look at 13. So on problem 13, we have the following. We have x over 1 plus x raised to the 4th dx. So what I'm going to do is I'm going to write this as x over 1 plus x squared dx. All right? So let's let u equal x squared. du is 2x dx. X dx, if I divide both sides by 2, is equal to 1/2 du. Like this. And so this is 1/2 the integral, right, of 1 over 1 plus u squared du. And it's very important that we recognize this. And so this is 1/2 arctangent of u plus c. But remember, u is x squared. And so this is 1/2 arctangent of x squared plus c. And that's how we do problem number 13. Let's take a look at problem number 14. Now, on problem number 14, we have the following. Suppose we had dx over the square root of 1 minus x squared times arc sine x. I'm going to write this in a very specific way. Okay. I'm going to write this as 1 over arc sine x times 1 over the square root of 1 minus x squared dx. And hopefully this gives you a little better idea of what you can call u. And if you remember, the derivative of arc sine x with respect to x really is 1 over the square root of 1 minus x squared. So a suitable choice of u would be arc sine x. Du is 1 over the square root of 1 minus x squared dx. And so this is the integral of 1 over u du, which is natural log of the absolute value of u plus c. But remember, u is arc sine x. So if we just come over here, we could write this as natural log of the absolute value of arc sine x plus c. And that's how you do problem number 14. Let's take a look at 15. So on problem 15, we have 1 plus x divided by 1 plus x squared dx. Now, the way I'm going to attack this problem is I'm going to split this fraction. So, in other words, I'm going to write this as 1 over 1 plus x squared plus x over 1 plus x squared dx. Okay. And so I can split it even further and get the integral of 1 over 1 plus x squared dx plus the integral of x over 1 plus x squared dx. Now, if we address the second integral, I'm going to let u equal 1 plus x squared, because then du is 2x dx. X dx is 1/2 du, right? So it's a straightforward u substitution. Now, on the next page, I get arc tangent x plus 1/2 the integral of 1 over u du, which is arc tangent x plus 1/2 natural log of the absolute value of u plus c. But remember, this integral has to be in terms of x. And remember, u equals 1 plus x squared. And so this is arc tangent of x plus 1/2 natural log of 1 plus x squared. And notice I don't need parentheses because 1 plus x squared is positive for all x. And then I just add c at the end. And that was problem number 15. Let's go ahead and take a look at another one. I'm going to throw this one in. Suppose I had the integral of cosine x plus sine of x to the second times cosine 2x dx. This is a really, really good problem because this is something we can do in Calculus 1. This problem is typically given in a Calculus 2 class, but there's no reason why we can't do it in this class. What it requires us to do is square out cosine of x plus sine of x first. And so what I'm going to do is I'm going to write this as cosine squared x plus 2 cosine x sine x, right? Plus sine squared x. times cosine 2x dx. Okay. Now, if we look at cosine squared x plus sine squared x, that's 1. Additionally, 2 cosine x sine x, we can replace that with sine 2x. And so this is the integral of 1 plus sine 2x times cosine 2x dx. And then from here, we can do a straight u substitution. So what I would do is I would let u equal 1 plus sine 2x. du is 2 cosine 2x dx. Cosine 2x dx is 1/2 du. And so this is 1/2 the integral of u du, which is 1/2 times 1/2 u squared plus c. But remember, u is 1 plus sine 2x. So this is 1/4 of 1 plus sine 2x raised to the second plus c. Right? And again, remember when it looks like we have to square something out, that's what I would tend to do. I would try to square something out and see if we can simplify the integrand first before trying to approach this problem. And that's how we do 16. Let's take a look at problem number 17. On problem 17, we have the following. We have 2 to the t divided by 2 to the t plus 3 dt. Let u equal 2 to the t plus 3. So du is 2 to the t times natural log of 2 dt. Now, divide both sides by natural log of 2, right? So 2 to the t dt is 1 over natural log of 2 du. And so from here, we're going to take 1 over natural log of 2 times the integral of 1 over u du. And if it helps, I would write the integral this way, by the way. You can write this as 1 over 2 to the t plus 3 times 2 to the t dt. And so you notice this piece of the integral was equal to 1 over natural log of 2 du. And so this is 1 over natural log of 2, natural log of the absolute value of u plus c. But u is 2 to the t plus 3, which is positive for all t. And so this is 1 over natural log of 2, natural log of 2 to the t plus 3 plus c. And that was number 17. Let's see if we can do one more for this video. And we can go from there. Suppose I ask you to evaluate the definite integral. And we're going to do more of these in a third video, okay? What changes when we evaluate a definite integral? And with that, I want to start off with problem number 18, okay? And it's the following. Suppose I had the integral of, and we will do this one. Let's see if we can try that again. Hold on. The screen slid up a little bit, so I want to just try that again. The directions say to evaluate the definite integral. And remember what I was saying, what changes? So we'll take a look at 18, and we're going to evaluate the following. Suppose we have the integral from 0 to pi over 6 of sine t divided by cosine squared t dt. So we're going to do lots of integrals that involve trigonometry in this class, in this chapter, okay? And so this is the integral from 0 to pi over 6 of sine t times 1 divided by cosine t times cosine t dt. And so this is the integral from 0 to pi over 6. Now, sine of t divided by cosine t is equal to tangent t. 1 divided by cosine t is equal to secant t dt. And so this is equal to secant t because that's the function whose derivative is secant t tangent t. And we're going to evaluate that guy from 0 to pi over 6. Now, I'm going to replace t with pi over 6, and so I get secant of pi over 6. Okay? And then I'm going to replace t with 0 and get secant of 0. So I'm applying the fundamental theorem of calculus, right? Now, let's come over here. Secant of pi over 6 is 1 over cosine of pi over 6. But cosine of pi over 6 is cosine of pi over 6 is square root of 3 over 2. So I'm going to write 1 over the square root of 3 over 2. And we can say this is 2 over square root of 3. And then secant of 0 is 1 over cosine of 0, which is 1 over 1, which is 1. So we come back here. This is 2 over square root of 3 minus 1. And remember, 1 is square root of 3 over square root of 3, right? And so the final answer here is 2 minus the square root of 3 divided by square root of 3. No decimal approximations. We need exact answers. And that'll conclude this video for the Exam 4 review, and we worked problems 11 through 18. Okay, thank you.